Very good afternoon to everyone. Can you hear me? Okay, good. Okay, so look at the list, we have 47. Okay, so hope that some will be joining. All right, before we start, let me share the QR code for the attendance. So please scan the QR code. So if you need the manual attendance, then please type your name and your matrix number in the chat box. If you need the manual attendance. So today indeed is very hot day. Actually, this morning there's some issue with the aircon at the universities there. So good day have online class, at least can you not be end up in a very hot room. So I guess everyone having the class from your home. Right. So even that the hot day also can become, if you notice that some of the research paper, they're also looking at how this temperature can affect the stock performance, right? Stock market performance. Right? So that's why it's very interesting to see that a lot of, what's going on around us can provide us with some ideas on the topic that you may be interested to look into, right? So even the temperature can become a topic, research topic that we can look into. So at time you can look at the temperatures and the stock market performance. So there could be some things that maybe interest you to look into. Right. So today, as I promised, we will discuss about the demo on the usage of the eViews. So I hope that everyone have already installed your eView software in your laptop, because now I'm going to do a brief demo on how you can utilize the eViews. Okay, and show you get the QR code on those who need to scan. Alright, so remember that the eViews is a part of the software or tools that you can use for the estimations. And the other software, like mentioned before, will be the Stata. Okay? So Stata and eViews are very important software that hope that you can master it, or at least learn the basic method on how to use those software. Because you never know, because next time if you are required to do some analytical analysis, then you can use this software, the eViews of this data, to run those analysis. Right? So again, as I mentioned before, to run the analysis is not that difficult, as long as I think you guys are younger generation, can learn very fast. Right? But what is important thing is you must know which method to use, and then how you're going to interpret the results that you obtain from the analysis. Okay? So that will be much more important. So that's why we need to look through on that part. Okay? All right. So please get your open up your eViews. So this is how we're going to do. The first part here, I will demo to you using a very brief, simple database, and then later on under the practice, another more detailed database that we provided to you, so that we can do this together. At least you can go through and you can understand how to transfer, especially transfer the data that you have in the Excel into the eViews, and then how to do some housekeeping on the eViews on the database before we can run the analysis, the multiple regression analysis. All right, so now if you look at the ellipse, so let me share the screen. So if you look at your ellipse under the learning unit 7 here, so later on you can look at the slide, but now let us concentrate on the demo. So you have two Excel files. So one is this eViews demo, and then the one is practice. So please download these two Excel files. So first for the demo, I will be using this eViews demo. So I hope that everyone are on the same page, because now I will start to discuss on this eView Excel file demo. So if you open up your Excel file, so let me share the screen for Excel. So this is how it looks like, the database. So in the page 1, sheet 1 and sheet 2, or the page 2 here. So this, let's say this is the information that you have, for example, like the GDP and the advertising expenditure, okay, from year 2001 to 2010. So this is how it looks like when you can look at the put it in the Excel. Is everyone looking at the same page here, the Excel? Yes, all right, good. So if you're looking at the different screen, please let me know, because sometimes you will end up discussing but showing the other files. So now we are looking at the raw data. So let us put it this term, the raw data. So normally this is how it is set up, because you have a different setup, then the way you run the analysis will be a bit different. For example, like this is the time series analysis. So this is the way how it should be set up, with the year, first column, and then followed by the variables that you want to include in the models. So year from 2000 to 2010, and then normally the second column here will represent the dependent variables. I think it's good that you just follow dependent variables, then followed by the independent variables. Okay? So that you will get yourself confused with the setup of the model's specifications later on. So we start with a very simple short time period to give you an overview of how to transfer all this data into the eViews. So this is how it should be set up. So time series is that one country, but across different years. So this also goes as well to the variables across different years. So the GDP, this advertising, maybe this is just another examples, variables that you can include. Right. So this is how it looks like in the Excel. But of course, we need to transfer, all those data to your eViews. Right? So there are three ways you can transfer your data, raw data, from Excel into eViews. So which one to choose, you will decide. Right? But I will show to you three ways or three options that you can consider to transfer your data from Excel into eViews. Right, so now let us open up your eViews. So let me share the screen. So this is if you open up your eViews, this is how it looks like. Okay, so the first, method transferring the Excel into the eViews will be through this import. Okay? So before we start with the import, you need to open up the new work file. New work file. So you open up a new work file. This is how it looks like. The work file create. So we have the work file structure type, dated, regular, and frequency. If you click this drop down menu, you can see that there are three options here. So the first one is the unstructured or undated. The second one is the dated or the regular frequency. The third one is the balance panel. So this unstructured or undated actually it refers to the cross-sectional data analysis. Okay. And then the second one, dated, means that regular frequency or known as the time series analysis. And then the third one is the balanced data. So it means that it's the combinations of the cross-sectionals and the time series analysis. So known as the panel data analysis. So you can see here, even in the eViews setup, you can, initially we need to decide which type of the analysis that we would like to run. Okay, so since this is the time series analysis, so we choose this one, the dated or regular frequency. Okay? So this is the structure types of the database which should be set up in your eViews. And then if you move on to the right hand side, you can see the date specifications, and then you can see the frequency. So this is also very important because you need to look at the date or how frequent the data is observed. Okay? So the frequency here, you can see that we can have the annually data, and then if you click down this drop down menu, you can see I have the semi-annual, quarterly, monthly, bi-monthly, fortnightly, 10 days, or weekly. So it depends. So most of the time, if it is the yearly data, then you choose this one as the annual. Right? So the start date just now is 2001, and that is 2010. Okay? So we need to state very clearly, start from which year and end at which year. Okay, so this is how it looks like. You create the work file. You let the eViews know that this is a time series analysis, and then the frequency is the annual data or yearly data, and then it start from 2001 to 2010. Okay, then you click OK. So this is how it looks like. You come up with this interface. Okay. So the next thing is you can import, right? So you go to the file here. You click here import. Okay. So import from file. Import from file. So this is you need to just now you download it. So you need to go to the file where you downloaded the eView demo. The eView demo. Open up. So this is how it looks like. Okay, click next. Just to overview. Okay, so make sure that everything is stated here, and then you click finish. Then link imported series and alpha objects to external sources. Then you can click no. Then you can see everything is appeared here. So you already transfer using the import the Excel file into your eViews. So you will transfer everything from the Excel data, raw data, into your eViews. Okay, so this is how you can transfer using the import function. Is it clear? Or I will do it one more time. I will do it one more time. Okay. You open up the eViews. Are we looking at the same page? The same page. Okay, good. Because sometimes it may hang. Alright, so you go to the file here, okay, go to the new work file. Then you look at the work structures. This is dated because this is a time series analysis. And then the date specifications, frequency is the yearly data, and then it's from 2001 to 2010. Okay, so this is the year. So this is the work file create informations that you need to have. Then click OK. So you have this, the general database you can have in the eViews. So now you need to import. Okay? You go to the file again. After you create the work file, you go to the file here. Look for the import functions. Import function, import from the file, right? Import from the file. Then you choose.
买了，它也是给你一样的东西。
Just now, the eViews demo, the Excel, in Excel form. Click open, then click next, or then finish. So here, link imported series, just click no. So you will transfer from eViews to your from Excel to eViews. So you want to look at it. Let's say the advertising, the GDP. Okay? You can see you can click GDP first, then you click the control button, you hold on to the control button, and then you use your mouse to click ADB. So the sequence will be from GDP first, and then the ADB second. So I repeat that, because you can select the variables based on the sequence. So this is how you can do it. Okay? You right click your mouse to this one, the GDP, and then you press the control button functions, and then next you right click the ADB. Okay? So you double click, open this group, you can see that the GDP will be appear in the first column here, and then followed by the ADB. Okay? So this is how it looks like, just like exactly like you view from your Excel. Okay, so exactly like the one you observe from the Excel file. Okay, so it's very simple, I guess.
Can you repeat it?
Import function, is it?
No, the just now GDP and ADB.
Ah, okay, GDP and ADB, yeah, alright. So it's this one. So let's say you want to click the GDP first, and then followed by ADB. So you use your mouse to right click this GDP, and then you press the control button in your keyboard. Control button, and then you click the ADB, right? Click mouse or ADB. So you have only pre-select these two variables, and then you just double click, open the group. Then you can see the sequence. Start with GDP, and then followed by the ADB. Okay. So the sequence is very important, because later on when you run the analysis, it will be easier, because you know that the first column here will be your dependent variable, and then followed by the independent variable. So this is how the eViews will read the database. Right. So I can close this, delete untitled group. So don't worry, just click yes. So then return back to the original interface here. So that is the first method using the import function. So now I will show to you, demo to you, the second method, copy and paste. Copy and paste. So this is how it looks like. Again, it goes to the create the work file. Okay? Same procedures. You create the work file. Click new work file. So this still remain the same. I don't change anything because the time series and the data here 2001 to 2010. Okay. So this is the general interface that you can get. Okay? So now if we opt for the second method, that is copy and paste. So this is how we should do. Okay? you go to here, the above function here, you go to this quick. See the quick here? After the prop, then the quick. Huh? So quick button, drop down button, you can see that there's a empty group edit series. Empty group edit series, you click. So this is how it looks like. Okay. Or see the interface from 2001 to 2010. Okay. So now you move upwards. You can see there's a blank. You notice that? That's why it's like this. Huh? You move upwards. In fact, there's the first row is blank. So this is where we need to copy and paste your Excel into your eViews. Okay. So now I go to your Excel. So this is what I mean by copy and paste. Huh? So Excel, you just copy the variables with all the data. The year, no need. You just copy the GDP, the variables name. Huh? The variables with the data. Okay. You just copy. And you need to paste at your eViews. Let me share the screen again. So remember just now, you created a work file. You move. That's how after created it's like looks like this. Okay. So actually you can move upward. So that there's a blank here. You paste. You paste, and all your variables, I mean the data, raw data already included in the eViews. So it will close exactly like what you have just now. Import functions. Right? Again, you want to check the GDP. You click the GDP with your mouse. Then control button ADV. Open as a group. So exactly like how you import, how you use the import functions to transfer the Excel into your eViews. Okay, so this is the second method. Okay, so I repeat the second method. I repeat again the second method using the copy and paste. You need to create the work file. So this is still the same, don't change anything. It's from 2001 to 2010. Okay, so this is the general interface that you will see. And then you go to the quick, yeah, quick. Then you choose empty group edit series. Empty group edit series. Right. So this is what you can observe from here. There's no empty space. Yeah? Then you click this arrow upward. So actually there's an empty space. So then you go to your Excel to copy. Excel, you copy the variable name and the data, excluding the year. Okay. Don't include the year. That's the variable's name and all the data. Okay. Copy. Then you paste in your eViews. So here's a blank cell here. Right click, paste. So this is how you transfer using copy and paste method. Okay, so now you already know two methods. Okay? So it's very important because most of the time the raw data will be in Excel file. So you must know how to transfer raw data into the eViews before you can do the estimation. Right, so you learn the import functions, the copy and paste functions, and now I will demo to you the third function, the third method, which will be even faster. Okay, so this is how it looks like. Huh? You go to your file, to your folder, Excel. You go to this one. Open up this one, please. Share the screen. So you go to the source, the folder where you downloaded your eViews Excel, and you just this is your eViews, huh? So you just drag and put it in your eView. Next, finish, click no. So we transfer into your eViews. So even faster. I think this one should be maybe the fastest ways to transfer from Excel into the eViews. So I repeat one more time. So you want to use search method. You just open up after open up eViews. You don't have to create the work file, no need. You just open up eViews, and then just drag your Excel, then put it in your eViews. Then click next, then finish, and no. So this is where you already can transfer your Excel into your eViews. Right? So why do I need to share with you these three methods? Because sometimes if the first or the second method doesn't work, then you can try the third method. Or if the third method doesn't work, then you can try the first or the second method. Okay? So this is how we should deal with things and always try to learn alternative ways to solve the same issues. So this is very important. You need to know different ways, different alternatives to solve the same issues. Alright, so is it clear? The three methods. So it's very easy. So now we really know how to transfer into your from Excel into the eViews. Right? So this is the first step that is very important. So now, assuming you already know how to transfer, from the Excel into the eViews. So now we need to do some understanding of the data of how we can utilize or instruct the eViews to do the work for you. Because the eViews can, handle more complicated, a lot of, large sample size, more data. They can do the complicated analysis for you. But you must provide, the correct command to them, or click, the correct buttons to instruct the eViews to do the analysis for you. Okay. So now, let's say, for example, that you want to, you can click the GDP. You just click one variable as GDP. So it's just like, the other analysis you can see here. You go to after you click one variables, click the views, then you can see descriptive statistic, even the histogram. So everything is here. So we can do this, the graph, for example, line. So the graph, everything is here. So the eViews can do these graphical illustrations for you. Okay. So it's very easy. You just go to after you choose the variables. Choose the variables. This is raw data. Then go to the view here. Then you can look at the graph. So this is in terms of the graphical representations. You can choose different type of these graphs. So this is how it looks like. Right. So now, what we can do is if you try to run a simple analysis, you click the GDP. You click the GDP first, and then you press the control button, then you click the ADV. Okay. So that the sequence, you can open the group, then you can see the sequence is the GDP first, then followed by the ADV. So in this case, then the eViews will read this GDP as a dependent variable. So the first column here normally, after a year, the first column here normally represents the dependent variables, and then followed by independent variables. Alright, so this is how we do the setup of the model specifications in the eViews. So next, if you want to run some analysis, you can see even the graph also can do two variables together. see what we have. Even can combine these two graph behavior.
你觉得它 register key 是每一个不一样的？
不是听我不能听话啦，我等下签完你自己去买个。
Alright, so now what is important here is we try to run some multiple regressions. Not multiple regression, just regression analysis. So after you open up as a group, then you can go to the second button here. After the view is the prop. Okay? The prop PROC. The prop. See the make equations. So we choose this one, the make equations. So this is how we can run these the regression analysis. So I repeat one more time. You open as a group, and you choose this prop. You click this prop, then make equations. Make equations, click. So this is how it looks like. The equation estimations, and this is the specifications. So this is sort of like your model's specifications, where the GDP, and followed by the ADV, the advertising, and then followed by the C to represent the constant values. And what is interesting here is the method that is outlined here. You will click this drop-down menu, you can see a lot of different advanced methods that is available in the eViews. And then these functions can be added from time to time. In the latest eViews versions, then you can see that a lot of new methods will be included here. So you can see here the LS is the least squared. Okay? So the least squared is the basic regression analysis that all the advanced analysis will depend on this one. Okay? It's just a matter of the assumptions or additional functions that is available, or additional functions that the new method can capture. Okay? So that's why it is different command or functions available under this method. So we will concentrate on this one, the least squared method here. And this is the sample size. Okay? So you go to the options. So this is normally we consider as this default, by default. Just let it as it is, unless you want to change. But most of the time we don't change much on these functions. Right? So this is the specifications, the least squared method. Then we click OK, and this is your results. Right? This is your results. So let's say I want to add on one more variables. So again, the same case, you can repeat. Click the GDP first, then followed by ADV, and then followed by the EX on the group. You open as a group, GDP, ADV, EX. So then the eViews will recognize that the first column here will be your dependent variable, followed by your independent variables. You go to the prop, make equations, and this is how it looks like. So normally by default, you will choose here the least squared. Okay, OK. So this is the result. So this should be considered as multiple regressions because you have two independent variables. Right? So this is how you can do the analysis. Okay? So if you look carefully here, let us look at the very brief overview on the results. So if you look at this result, let me transfer this one to reverse so that it looks bigger. Let me share the screen of these also words. Okay? So this is the result that we obtained just now. We just copy and paste and put it in the words so that will be easier for us to discuss here. Look at it. So you can see here, they put it here as a dependent variables, the GDP, right? So it's stated very clearly here. And then you know that this ADV will be your independent variables. And the EX also the independent variables. And then you can look at this is the coefficients, standard error, the T statistic, and the probability. So that's why no matter how you run the analysis, this is the result that you obtain. So most of the time we will add a few importance indicators here because we need to remember the 3S, significance, the size, and the sign. Okay? So that's why this is very important, so that we can decide especially which variable is statistically significant or not. Okay? So maybe from here, can anyone tell me, is this variable significant? Is this variable statistically significant? Okay. Yes. Okay, good. Why? Because it is less than 0.0062 is less than 0.05. So that's why you have enough evidence to reject the null hypothesis. How about the EX? Is this variable statistically significant? Alright, no. Alright, good. No. Because 0.8 is greater than 0.05. And then how about the constant values? Is the constant values statistically significant? The constant value is statistically significant. Yes, alright. Because the same concept. So it doesn't matter what variables that or parameters that we're looking at it. I mean, the concept still remains the same. Right? As long as less than 0.05, then we can reject the null hypothesis. Alright. R squared 0.73, so about 74%. Okay? The changes in the GDP can be explained by the changes in the ADV and EX. So 0.7 looks okay. It's quite average. I mean, quite high. So everything looks fine, but this is not considered a good result. Okay? So although there are some variables are statistically significant, the R square is there 0.7, and if you look at the coefficient, so the coefficient here, it triggered a concern of the variables that you use for the estimation. So why I'm saying like that is because if you look at this, the coefficients change is 19.08 for the ADV. So it means that if the one unit change in the ADV, and the GDP will change by 19.08 units. But for the EX, the impact is the GDP will change by 0.19. But if you look at the constant values, is 374. Okay. So what is 19, 0.9, and then this is 300. 300 are the coefficients. So there's the gap or divergence in terms of the coefficients here. So sometimes if you get this kind of results, it means that something is not right. Right? So it could be something wrong with your raw data, right? Or the way how you treat the raw data. Right? So there's one way that how we can solve or overcome these problems. So we need to understand why these problems arise. So this problem may arise due to the different measurement units that we have. For example, like the GDP could be in trillion or billion, and the advertising maybe this is export for examples. So they may add up with the different measurement units. For export, be just in $1,000 US. Different measurement units. If you run the analysis using the raw data, you may end up with some unusual outcome. For example, like this one. You can see the constant value is 300 plus, but the other coefficient is small. Even for this EX export, the coefficient even small, 0.19. So that triggers a concern for us as a researchers that we need to relook into your raw data. And one of the possible reasons contributes to these results is the different measurement units. So therefore, we need to do some data cleaning on their raw data. So now it goes back to your share the screen. So we need to do some data transformations. For example, this is where we can do. You go to this button here, generate. So generate series by equations. You look at this, the view, the functions button, parallel with the view prof. You move horizontally to this generate. Or look at the last one, sample. Then the left hand side of the sample is this gen. This is the generate. Click this one. It refers to the generate series by equations. So this is the command that you can provide to eViews to instruct eViews to do certain functions for you. You try to do the calculations by yourself, but you can let the eViews to do the calculations for you because the eViews can handle, So this is how we can do. For example, now what we intend to do is to transform the raw data into logarithm. We transform all the raw data into logarithm. This means that we log all the data. So if you want to log all the data, there are certain commands that you can use. So this is how it looks like. So I don't have to put it in the chat box. So we put an L here. This is L. ADV equal ADV equal log bracket ADV close bracket. So this is the command that you have. Let me put in the checkbox.
review 下载哦。
没有。我帮你注册了，你这。OK。
Now look at the checkbox. So the left hand side is the L ADV equal to log ADV. I hope that you can see this one. Screen again. So this is how it looks like. I put in words so that you can see. So this is the command. The L, this is L. L ADV equal to log ADV. So this side is the new name of the variables that you create. You want the eViews to create. Because the original variable is ADV. But you want to create a new variable H is after being log, so we transform into a logarithm. So the L normally refers to log ADV. So this is the name that you provide, so that you know that there is a new variables created. And then equal to the log, the right side here is the command that you need to provide for EBUs to run. Instruct EBUs to do it for you. So EBUs you read as you log this ADV, because this is the original data in the database. Log ADV. So we can try the second one, L GDP. The new variables that you want to create equal to log open bracket the original data available to EBUs and close bracket. So you try to perform these two, then you can see what you get. Right? So this is very important in terms of the data setup. So go back to your EBUs. So if you click OK, then you can see that it's a new variables being created. So if you do the same, repeat the same process, GDP equal to GGP. Okay, so you can see that there's a new variables created. You can also try the LEX, the log EX. So you have a 3 L original variables, now with the 3 new algorithm form. So the next thing is, why not we try to rerun the analysis again? Okay? So this time you click the LGDP. You use the mouse right click the LGDP. Right your left click your LGDP. Then press the control button at the laptop keyboard there. Then choose the LGDP, then followed by LEX. So open as a group. Just to observe, you can see that the values change here. So if you want to look carefully, what is the other changes? So I can click the LGDP first, then followed by GDP, then LADV, followed by ADV, LEX, followed by EX. Because I want to show to you what are the changes that it makes. This is the new variable created. This is the original for the GDP. The ADV new variable created is the original. The EX created, this is the original. So you can see even from this 500, the GDP now becomes 6 point something. So 500, some are 400 plus. Okay? So but now you can see that the gap or the variance has been reduced a lot. The variance of the dispersions has been reduced a lot. So that is why the transformations of into a logarithm sometimes is very useful and it's very important. If you are handling different measurement units, then there's a need for you to standardize the different measurement units by transform the raw data into logarithms. Right? So now let's try to rerun the analysis. Now we use the log variables LGDP followed by LADV and LEX. So you open as a group just to double check, make sure that the first column here is your dependent variables and then followed by your independent variables. So the first column is very important because you need to decide which one is your dependent variables. And then the second and the third column, it doesn't matter which one comes first because they are just the independent variables. But the first column here is very important because this the EBs will treat this one as your dependent variable. Then you go to the prop and make the equations. Click OK. So this is the result that you will get. Okay? In terms of significance, it doesn't change much, but you can see that the coefficient change. At least now, that's like 500 something and 300 something, so now become 5.7. So you can see that, I mean, the impact of if you transform your raw data into the logarithms, it changes a lot your outcomes or the results of your estimations, which will be much more rational compared if you using the raw data. Right? So this is normally how we run the analysis using this the logarithms data. So far, is everything clear? Do you have any questions, or do you need which part that you need further explanations or clarifications? Please let me know. So your project will be something like this. You need to run until this stage. Okay? So remember, I would like to inform that this is still considered as a very basic. When we do the time series analysis later on, we will show to you some of the advanced method that you can consider later on for your FYP. Of course, your FYP cannot just end up with this multiple regressions. It has to be something more than that. But this is OLS is very important because no matter how advanced your analysis, everything is still based on the OLS estimators. That's why I showed to you the derivations, how do you get those estimators, the properties of the estimators, because all the estimations is based on the OLS estimators. Okay? Because I would like to highlight this one because I don't want students to have the thought that the OLS already obsolete. It's the old versions, so it's not important. So that is totally wrong, because even if you look carefully, the advanced analysis or use the quantile regressions or use this nonlinearity threshold regressions, everything is still based on the OLS estimators. It does that they have different assumptions or different functions they are able to capture, but the basic estimations is still based on the OLS estimators. Right, so now most of the time, that's why we need to transform the data into the logarithms so that the results look much more rational comparatively to before you transform into the logarithms. So even here, you can click here the estimate here, so it will be faster. Function, you can go to this pop-up function here. So rather than goes back to the the spreadsheet, but you can click this estimate, then you can change wherever you want from here. Right. So the next thing is you go to the view here again. You go to the view, and then the drop-down menu, you can see there's a residuals, there's stability diagnostic. So this is considered as the diagnostic testing that we must provide when you do the time series analysis. Right. So most of the time we look at this one. For example, the residuals, you can see a normality test, serial correlations, heteroscedasticity test. If you click this one, histogram is the normality test. So you've seen this result, this kind of result before last week. You look at this, the graphical presentations. So they are testing. This is not as the normality test. You want to test whether the residuals are normally distributed or not. It's based on the Jack-Barra coefficients. Okay? So we have a lot of information here, but we only concentrate on this one, the probability. Right? So can anyone tell me, is this result statistically significant or not? So is this result statistically significant? Look at this one, the Jack-Barra, the probability 0.78. Is this significant? No, alright, good. No, because 0.7 is greater than 0.05. So you can see that, I mean, the different type of testing, different results. But at the end, when it comes to the significance, to determine whether the variable is statistically significant, it goes back to this probability approach method to decide. Okay? So that's why in the first class, I will start to stress or highlight on the importance of this probability approach that you can use for your decision rules to reject or not reject your null hypothesis, which can help you to decide whether the variable is statistically significant or not. Right? So this is, you cannot reject means that the residues are normally distributed. Then you go to the view again, you go to the residual diagnostic, you go to these serial correlations. So serial correlations, remember, under the one of the classical assumptions where they assume that the correlations between the two error terms or disturbance are equal to 0. The correlation is equal to 0. So that's why we can test it based on the result that we have under this serial correlations Lagrange multiplier test. LM is a Lagrange multiplier test. So here, lag specifications by default you put 2. You can change 3 or 1. It depends, but most of the time it's by default is 2, or you let this system generate for you. So this is your Bruce Godfrey serial correlations Lagrange multiplier test. Okay? So here you can see the F test here, the probability, and then the observations times the R squared, and then this is the probability of the chi-squared. So normally we look at this one, the probabilities of the chi-squared. So it looks complicated. See, the result looks complicated, but in fact it is not, because you just need to identify which information that is needed for you to make the conclusions. So the serial correlations, we are looking at whether the error terms are serially correlated or not. Okay? So that will be your null hypothesis. So if you look at the results here, so here the F test, it doesn't matter, but we will concentrate on the probability. So there are two probabilities here. One is the F, one is chi-squared. So we will look at the chi-squared probability. So what's the values? It's 0.3232. Can anyone tell me? Can we reject or do not reject the null hypothesis? Can we reject the null hypothesis based on this result? .3232. No, is it question mark or answer? So this is probability for the chi-squared. It's 0.3232. Again, you refer back to your guideline. The probability values compared to the significant levels. 0.3232 is a probability value. And then you compare with the 0.05. So which one is greater? 0.3232 is greater than 0.05. So you do not reject the null hypothesis. You do not reject the null hypothesis because 0.3232 is greater than 0.05. So what I'm trying to say here is the probability concept never change. It doesn't matter of this probability is for the F values or this probability is for the chi-squared. But the way we do the interpretations based on this probability approach remain the same. So that's why this is what I'm trying to mention to you all. Right? The test can be different type of testing. It doesn't matter because the core concept is still remain the same. The probability approach. You just need to know what is the probability value and then what is the significant levels that you choose to compare. That's all. If the probability value is less than the significant levels, then you can reject the null hypothesis. If the probability value is greater than the similar levels, then you do not reject the null hypothesis. So if you look at this way, then it will be much more easier for you to remember. Right, so we can try again. Go to the residual diagnostic, and then you can see this heteroscedasticity test. So remember, hetero, based on the classical assumptions, it refers to the variance. So we want to see whether the variances are constant or same for all the observations, or each of the observations carry different variances. So this is what this heteroscedasticity is testing. Hetero means different, scedastic means dispersion, right? So if we click this button, you can see here even under this heteroscedasticity test, there are different types of testing, the BPG, Bruce, Pagan, Godfrey, or even Harvey, and the Mike. Okay? So a lot of different types of testing. So we can use the first one, BPG. Okay. Then you can see here there's a lot of information available. Again, we concentrate on this one, the chi-squared. So even these two chi-squared, I mean, you add up the same conclusions here. Right? So normally we aim for this one, the observation times the R-squared. So we look at the so this is the probability chi-squared that we're going to use to help us to decide whether to reject or do not reject the null hypothesis. So in this case, heteroscedasticity test, the null hypothesis will be the variances are constant. The variances are homoscedastic. So that will be your null hypothesis. Then we will look at the probability values. So this probability values is 0.1221. Is this greater than 0.05? Definitely yes. Okay. So then we can see that we do not reject the null hypothesis. We do not reject it because 0.1221 is greater than 0.05. So then we can conclude that we agree with the null hypothesis of the variance are all constant. So this means that the variance are homoscedastic. Right? So now I'm trying to show to you how do we interpret the results here. Because later on when we go to the structures of this diagnostic testing learning unit, we'll look into detail again. At least now you can have some ideas on how to run the analysis and to provide a very basic interpretations on how do we make the conclusions based on the results that we have. Alright, so then we can go to view again.
如果你看那个 video， 你会发现到你的代码是一模一样的。
So this is Ramsey reset test. Ramsey reset test is to see whether the model is there any misspecifications in the models. So let us have a look at this one. Click OK. So normally they put the number of fitted terms as 1. So click OK. So then you can see again. A lot of information available here. But you only concentrate on this one, the one with the so even here you can see the different t-test, f-test, or likelihood ratios. Normally you can look at the test here. So all we end up with the same conclusion because all the probability from here they are greater than 0.05. So we do not reject. Right? So another one interesting part you can see is go to the view again. You go to this stability diagnostic. You look at this recursive estimate. Go to stability diagnostic. You go to this recursive estimate OLS on. To the recursive estimate, click. The recursive estimations. We can do two stability tests here. So the first one I try is doing the Kusum test. Cumulative sum of square. Kusum test. Click OK. So this is the models I can see, right? So you can see the diagram. It's moving the blue color. The red dotted is the boundary. The blue line here is showing the models how stable it is. As long as the blue line here is within the red dotted line, then the model is considered stable for the sample period. So in this case, so most of the blue line here falls within or inside the dotted red line. Right? So this is still considered as stable because sometimes it may breach or beyond the red dotted line. That indicates that the model is not stable. So there could be some outlier exist in your database. So you can try again. Go to the view, and then you go to the stability diagnostic test here. You go to this recursive estimate. Okay. Just now we try the custom test. Now we try the custom spread test. Custom spread test. Right. Click OK. So again, you can see this is the models. So you want to look into specifically, you can see here at which year, around 2007 and until 2009. So there are some, these unstable in this case. But as a researchers, we look at the overview. As long as most of the blue line here falls within the red dotted line, then we can assume that the model is stable. Okay? Although there's a breach at this period, but at least it bounced back. Okay? It bounced back into the red dotted boundary. So in general, this is still considered as stable models. But the best model is all the blue line will be within the red dotted line. And we can be very sure that the models that we use is very stable, right? So yeah, two types. One is custom spread, one is custom spread test. So again, this is the residual stability test, and then this is the stability test. So that's why the name stability diagnostic. We want to test whether the model is stable or not. Right? That's why besides doing the estimations, sometimes we also need to run some diagnostic testing to ensure that the results or the models that we use can be trusted or reliable. So it's not just about the OLS estimators like the properties, the linearity, unbiasedness, efficiency and consistency, but we also need to look at the model as a whole, the overall models. Can we claim that the model is stable, or can we claim that the models doesn't violate some of the classical assumptions such as the serial correlations or this heteroscedasticity test, or even the normality test. Okay? So to run the analysis is not that easy, because we need to incorporate a lot of different perspectives to ensure that not just the OLS estimates the results, but also to ensure that the models is rational and it can be trusted and can be used for the policy recommendations later on. All right. So far, are you clear on the procedures? We run the multiple regressions, and next is also to run the diagnostic test. Do you have any other questions? Not clear. It's been very easy. Yeah? Right. So if everyone is clear, then if you look at your ellipse. So there is one Excel file in the practice. So I would like you to try. I would like you to try this one, the practice. You download this one and then you transfer into your e-views. Can you please do it now? before you forget. Okay? So now we have a different structures database, a longer time period, so you can try. The first of all, we like to try to transfer from Excel into emails. So I will demo to you 3 methods. So which one to use? It's up to you. You want to use the import functions? That's fine. You want to use the copy and paste? That's fine. Or you want to just drag the Excel file into the email?
你们刚才来听了教这个教多久？
You are able to transfer
2点到4点这样子。
讲多久啊？
3个拜5其实就有。
Can you please do it now?
很多光出来了，就看起来好像看 investment 的那一种。
之前也会出现这样的东西吗？
So are you able to transfer? I think it should be very fast, right?
都完了就大帽子。
The drag file, right? It will be very fast.
没有啊，
Fast or slow?
没有妈鸡掰！我看一下，我问你，你有没有做过这个东西？你可以。
我做过，我知道。哦，
他没牛啊！
好，
我是不是跟你讲 offline？ 我刚才不是，我看一下我有没有跟你讲 offline？
我刚才也有 offline 啊。
那个晚上
Because sometimes the import function may have some issue with the software. Sometimes the import function doesn't work. Then you need to use the more conventional ways like copy and paste. So sometimes you try to drag the file, it doesn't work. Then you need to use the other method. So that's why I think it's important to share with you
你注册的时候要
three
offline，
different methods.
你在安装的时候要 offline， 然后你应该不是下午有用那个 Windows Defender 什么那个就是把它弄它这个东西会知道来，所以它就不会问什么要不要更新什么授权什么的。
这样就是按到啊。
没有，你没有断来是就等于。
你下午用的时候有没有断来？
没有收到赛。你就讲你有没有？
我下午都没有开到来，只有现在的时候。
So now
然后你再安装啊，跟着安装啊，没有那个弄下去啊。
there's different measurement units like the GDP, the FDI, the E, the export.
这样子美国的那个时候就不可以按 line 了。
你那边就开掉了没？
You have this gross fixed capital.
因为我
你跟我讲，你什么时候开始开来？
For example,
美国那边。
so you have a different measurement
因为
units. So it would be good.
用到这个。
First thing that before you run the analysis.
我讲下午
为什么没有？
Transfer
下午能够。
data into the algorithm.
现在
So if not, this is how it looks like. For example, you want to use the GDP
我不知道你
as a dependent variable.
自己去买个新的。
Then choose the API or the export.
这样我买书不是也会看到？
我跟你讲，他给一样的方，不相信我。
Max equations. You can see this is the result that you get. Right, this one appeared here.
这样子我能够买另外一个 PB
You
了
don't。transform the algorithm. So this is the result that you get. Choose the GDP and API.
他们讲话没有。
So we don't transform into the algorithm. We use the raw data
有，
directly.
我们当时
So
是
this
下到的东
is
西。
what it looks like.
后来说现在不应该是在。
The R square is very high, 0.89. But you can see this one.
后来找不比。
0.6 for the API.
我应该 FIBS。
1.2 for the export. But you can see for the constant is 10 plus 10. E plus 10 means that 10 decimal points plus means that to the right hand side.
现在去上课。
10 decimal points to the right hand side means that this value
啊，
is
你看这
extremely
种来，
large. The value is very large.
那个
So
人
it doesn't make sense at all.
那个有哪一个男
So
的
you
吗？
can see that the result
别的
is very weird, unusual.
那个找了
So it cannot be used
FIBS。
because it's questionable.
我听了
Something must be wrong with the way how we treat the original data. So we need to do some transformation
啊，
on the
是不坚强，要骗
So
我。
now let
不
us
是
try
骗我了。
to get rid of this thing. Let's try to create the new variables. So let's try to generate. Great. Right, so now we try to generate whatever the E. Okay, we try to generate E. Export. So let's create the new name LE. The LE equal to log L or G log open bracket E close bracket. So that will be the first one. So you can see that new variables being created. Then try to API. Again generate L API equal to log open bracket API the original data and close bracket. Okay. Then here the new variables created. Then you try the GDP. Try the GDP. Alpha GDP equal to GDP. And then you have this the G. Yes, here is gross fixed capital formations. Right. L G F C F equal to log bracket G F C F close bracket. So far is everything okay? You try to log the E, log the API, log the GDP, log the GFCF. So practice few more times, then you'll be very familiar on how to transform the raw data into the algorithm before you can run the exclamations. Alright, so the next one is this INF. This is the inflation. So you look at for the interest rate LINF equal to log INF, see what you get. Then notice that sometimes you may have like this lot of non-positive numbers, missing data generated. So if this message pop up, it means that you cannot log the negative values. So it means that your original data consists of negative values. It's possible because sometimes it indicates reductions until it reaches the negative values. So we cannot, by the mathematical concept, we cannot log the negative values. So is it correct? So look at, you open up this inflation here. You open up this file. Then you observe that there's a negative value here. In year 2020, the negative value was negative 1.188. So therefore, we cannot log the data. The users cannot perform the logarithm transformation for negative values. So this means that we need to do some touch up on this data. We don't change. Okay? So never ever change the original data. It's not ethical to do that. But we have a way to overcome it. Okay? Either you can use the formula, or the easiest way is you change these variables, these values into positive values. Because this is the negative, means that this is the lowest values, negative 1.1. How to transform these values into positive? How to transform? The easiest way is you can negative 1.13. So maybe just plus 1.1 and 1.2. Because 1.2 for this one, then this value will become positive. 1.2. So you plus 1.2 for this year. So the other year you also need to plus 1.2. Why? Because we do not want to change the trend or the pattern of the data. So if you add 1.2, well, 1.2 or 1.5, it doesn't matter as long as you can change these negative values into positive values. So why 1.2 for all the other years? Because we don't want to change the pattern. So the pattern will still remain the same. Because remember, when we run the analysis, we are not estimating the absolute values, the values for this year or that year. No, we are actually measuring the changes from years to years. So the trend or the patterns that is the one that we are estimating. We are not estimating the absolute values, but we are estimating the changes from years to years. And so this is what a analysis or the estimation is all about. Okay? So if this one plus 1.2, then the rest plus 1.2, so you let the EViews to do it for you. So just this one. So he can instruct the EViews to do it for you. So that's how it looks like. You're going to generate. So let's say I want to create a new variables, and is new inflation variables, I and F. So equal to the original I and F plus 1.2. So that it means that all the years will be plus 1.2 under the inflations of I and F variables. So click OK. Then you see there's a new variable created. So this is the original. This is new. I open up to show it to you. So now this is the original. The negative values, you plus 1.2 become positive. So all of the years you also plus 1.2, so that we will keep the trend or the patterns remain the same. It doesn't change. Okay. So in that case, we don't change the data. No, because we still remain the pattern or the trend of the data. Right. So then we use the new variables they created, and you generate again to log L I and F equal to log the new variables they created I and F. You just break it. Then you have the new variables created here. L I and F. So now, because all the data is the positive values, then you can log the data. Right? So why I show you this? Because I noticed that a lot of you, the groups are proposing to study on the inflations or use the inflation as one of the independent variables, and you may encounter these problems where you cannot perform the logarithms or the negative values. So this is one way how you can overcome these problems. Right? So you may come across this, trust me, when you do your group project, because most of you are using these inflation variables, and sometimes these inflation variables are, in certain years, they are in the negative values. So remember that there is that link. So now you can try use the LGDP and LDI export. You can try all the variables. Okay. You can open this group just to double check, make sure that everything is correct. So all are in the logarithm form. You can see that the variation has been changed, reduced. So the gap has changes. The variation will be very small after you transform into the logarithm. Then you go to the prompt here, make equations, and click OK. So this is the result that you will get. This is multiple equations. You have 42 observations. See, R square is very high. Then see this first variables is not significant, and the rest are significant. So you need to practice to learn how to do the interpretations, so that until you look at the values here, then straight away you will know, to give you some ideas which variable is statistically significant or not. Right? And then now we can try also to look at the diagnostic test, for example, like the residual diagnostic for the normality test. Click. So again, this is we do not reject the null hypothesis, means that the residues are normally distributed. Again, try to use the serial correlations LM test at 2 x to equal to 94. So now you can see here. Do we reject or do not reject the null hypothesis in this case? Null hypothesis is the error terms are not serially correlated. R. What is R? You know what do you mean by R? So is this do we reject or do not reject the null hypothesis under these results? Reject? Yes, okay. Oh, the R is reject, okay, sure. Alright. The R is reject, yes. Reject, so because it's 0.00, it's very small. So less than 0.05, then we can reject the null hypothesis. So it means that you reject the diagnostic test. It means that the error terms are serially correlated. So they could be problems or considered as violations of the classical assumptions. Right? So I showed just now, the first example we showed to you is follow the diagnostic test, fulfill the classical assumptions. So this result showing that based on the new sample results, is violations of the serial correlations assumptions. So how about we try another one? Look at the residual diagnostic test for the heteroscedasticity test. You click, and then BPG, and OK. Again, look at the observations times the R squared. Look at the probability chi-squared. But it doesn't matter, you can see all of the probability values, they are less than 0.05. So in this case, these models also suffer not just serial correlations problems, but also suffer heteroscedasticity problems. So sometimes when you run analysis, you may encounter different type of the outcomes. So sometimes if you're lucky enough, you will get everything according to the classical assumptions. But sometimes it may not be the case, where you can see some of the diagnostic tests doesn't pass through the classical assumptions. Like this example. Then you can try the stability test. Maybe you can straight away look at the recursive estimate. Look at the Coulson test. So this Coulson test is a big problem at the end here because it reached outside the rate total line. Then at least it provide you some ideas on which year onwards. After 2016 onwards, there's a divergence where the blue line is exceeding the rate total line. So you can try also looking at the recursive Coulson square test. So you can see here, most of the blue line here is outside the rate total line. Although it bounced back, but you can see that it's quite, large portions of the sample indicates exceeding the rate total line. So it may not be quite stable in this case because it is mostly outside the rate total line. So it means that at least it gives some ideas. If your structures, you choose the independent variables and the rest are the independent variables, based on the sample period, this is the result that you will get. So it suffers a few diagnostic problems, such as the serial correlation problems, heteroscedasticity problems, and also this stability test problems. It does not get through. So that means that you need to relook into your model's specifications, or relook into the data that you have, or maybe you need to try different type of the data, or different data, or different variables. Different data as a proxy for your variables. Right? So So this is something that you need to consider. Right? So far, is everything clear? So what I would like you to do for the remaining of the class is I want to run the analysis using these models under this practice Excel file. Right? So what I want you to do is so what I would like you to do is I want you to treat this FDI as your dependent variables. FDI is independent variables, and then followed by the others. Let me put it this way. FDI, let me show this one. FDI, then followed by GDP. And put it in the checkbox. So I would like to model like this. So FDI as a dependent variables, GDP, GFCF, INF, and LE as the independent variables. Okay. So the model specifications will look like this. So what you need to do is you need to transform. You need to practice again. That's why I would like you to practice. Transform all the raw data into the numerator, and you do the estimation based on this. FDI as the dependent variables, and log GDP, log GFCF, log INF, and log LE as the independent variables. You run the multiple regressions, and then you run the diagnostic tests such as the normality test, zero correlation test, heteroscedasticity test, and also the custom test and the custom spread test as part of the stability test. So this is what I would like you to try to do for the remaining class. So you need to practice so that you will remember. Okay? Practice and you remember. So don't worry, I also do the recording for this class. So that I will share with you this recording just in case some of you need to refer lectures. Right, so far any question? Do you know what to do? Use the same database. Now I model it differently. Okay? So I model it now as where the FDI as a dependent variable, then the rate, the GDP, GFCF, INF, and the LE, and the export. So this is the original data, the EN. So you need to transform or using the logarithm data to run the multiple regressions. Then you show to me what's the result that you get. So I mean, what you need to do is you just can copy it. You use here. After you get the result, for example, you can just copy this one, copy, and then put in the words. So that then you know that this is the result that you get. Okay? So even you can run the diagnostic test, for example, like serial correlations. Okay, so you just copy this one, we do. Then just need to see this. But this is not the concern here. So I just need to copy and pass it in the words. So they have different type of the EBS results. So this is very important because in the exam later on, final exam, you may expect to see something like this. You have the estimated results, then from there you need to do the right? So that's why I want you to try to practice now, so that you are more prepared for your final exam, and also this is also important for your project completion. So you need to do something like this. Alright, so you look at the checkbox. So this is the models that you should set up. So is it clear? Okay. Alright, good. Alright, so so I think for this online class, for this week, so the online lecture will stop here, and then I would like you to for the remaining of the class, okay, that you can do this exercise. Use this FDI, GDP, JFCF, INF, and E as the model specifications, and then we like to practice again using these e-views step by step. You need to practice, and then show it to me, put it in the words, and then I will put it in the forum place for you to submit to that one. Practice now so that you will not forget. If you wait for tomorrow, then worry that you will forget.
学过了没有
Right?
我直接找另外一个找麦讲嘛。
So later on, I will also put in some announcement on some of the tutorial questions that you need to submit. At least by the end. So later on, I will share the information. But for the remaining of the class, after you look up also later on, for those who want to continue, please do this exercise, and then you copy and paste in the words, and then submit in the forum there. And later on, I will provide a link for you to submit. Right? So, any other questions?
Sorry, sir. I want to ask. Oh, yes, we need to submit in the forum. Is it only for the equation?
The output, the e-views output.
Or is it include the residual diagnostics, the use of current figure correlation characteristic?
Yes, just copy and paste. Yeah.
Okay.
Very easy. Just copy and paste. Because I want to practice the run analysis.
Show us lah.
Yes.
Okay.
Yeah.
Thank you.
Alright, copy and paste in the words and submit. Okay. Any other questions? No. Attendance? Just make sure that everyone got your attendance. Yes.
On the group assignment, the link of the journal article that you put in the instruction of the file, the instruction for the group assignment, we cannot access it.
Is it?
Yes.
Oh. Okay. Later I check. I check for it later on.
Alright. Thank you, sir.
Okay. So I hope that you will already started. I mean, to proceed with your group assignment project, group project arrangement. So make sure you start to do it and don't wait until last minute. So you should start to do it now. Because we almost covered most of the important parts. So I think by now you should be able to proceed with your estimations. Alright, so no other questions? So if no, then I think next week we still have class. Actually, yeah, if no changes, so next week still is online class. Okay. Right, so for the remainder of the class, for this week, for the remainder of the class, I will let you do this exercise. Okay, so if no other questions, later on I will also share the recording after you're ready. In WebEx, I will share with you the recording just in case some of you would like to refer. Alright, so if no other questions, then I think that will be all for these online lectures. So please do stay safe and take care. Alright, so that will be all for today's online lecture.